Welcome to the session. In this session, we'll be discussing about series circuit. Many times in electronics, we need to make the use of series and parallel circuits. So whenever we have been provided with certain resistances, we need to connect them either in series form or we need to connect them in parallel form. So whenever we connect the resistances in series form, then there are certain properties that are being associated with this circuit. So in this session, we will discuss what are these properties that are associated with the series circuit. Friends, we are recording this session by making the use of the iPad. So let us understand what we mean by series circuit. When two or more resistances are connected in sequential form, that is one after the other, are connected in sequential form, then the circuit is called as series circuit. So in the series circuit, the resistances are connected in sequence with each other. Say for example, if I am having three resistances, resistance R1, R2 and R3, and if these resistances are connected in this fashion in sequence with each other, then such circuit is being called as the series circuit. And suppose a battery voltage V is applied to this circuit, then this circuit has certain properties. The first property is that the total resistance of the circuit R is given by R1 plus R2 plus R3. That is, when the three resistances are connected in series with each other, then the total or effective resistance of the circuit is summation of all three resistances. The second property is that the current flowing in the circuit is same. That is, if the current flowing in the circuit is I, then the same current I will flow through all the resistances. Current I will flow through all resistances. That is, the current flowing through the series circuit is same and it is given by I, where we can write I is just nothing but V divided by R, where V is the voltage applied to the circuit and R is the total resistance, where R is equal to R1 plus R2 plus R3. The third property associated with this circuit is, suppose V1 is the voltage drop across R1, V2 is the voltage drop across R2 and V3 is the voltage drop across R3. Then the voltage drop V1 is equal to I into R1. Voltage drop V2 is equal to I into R2. And the voltage drop V3 is equal to I into R3. So the voltage across each resistance is given by current multiplied by the value of the resistance. And the fourth property is that the total voltage V is just nothing but V1 plus V2 plus V3. So whenever we have been provided with a series circuit where the three resistances are connected in series with each other, then the total resistance or effective resistance of the circuit is R is equal to R1 plus R2 plus R3. In series circuit, the same amount of current will flow through all the resistances, and it is given by I is equal to V upon R, where V is the voltage applied to the circuit and R is the total resistance R1 plus R2 plus R3. The voltage drop across each resistance is different because the value of the resistance is different even though the current is same, and therefore voltage drop across the resistance R1 is V1 I into R1, V2 is I into R2, and V3 is I into R3, and the total voltage in the circuit is given by V is equal to V1 plus V2 plus V3. Another property is of voltage divider. It is possible that you can form a voltage divider circuit by making the use of the series circuit. Now suppose we have been provided with a battery, and suppose these are the two resistances. Suppose this is the resistance R1, this is the resistance R2, this is the voltage V, and we know that the current flowing is I. Now we can calculate the voltage drop across the resistance R2. Now the voltage across R2 can be given as V2 is equal to current multiplied by the value of the resistance R2. But the current flowing through the resistance R2 is just nothing but V divided by R1 plus R2 into R2, and therefore the voltage across the resistance R2 is V into R2 divided by R1 plus R2. So this formula is very useful in order to calculate the voltage across the resistance R2. So such a circuit is being called as a voltage divider circuit, and this circuit is very useful in many electronic applications. Say for example, when we make the use of amplifier and when we apply the input voltage to the amplifier, then this input voltage has to be reduced, and this reduction is possible by making the use of the voltage divider circuit. So voltage across the resistance R2 is given by V2 is equal to V into R2 divided by R1 plus R2.